So in a right angle triangle, basically all of last class was me trying to justify how this works. So in a right angle triangle, we have these ratios that allow us to relate angles and sides to each other. If the angle is the same, the ratios are all the same. That's what we were looking at here in these ever-increasing similar triangles. And then I told you that these ratios all actually have names. We have the sine ratio, which relates the opposite side with the hypotenuse. We have the cosine ratio, which relates the side adjacent to an angle and the hypotenuse. And then we've got the tan ratio, which relates the opposite side and the adjacent side to the angle that we're working with here. So, let's go through and use these things, shall we? So, today is just going to be largely a bunch of examples, and we might jump into the second lesson here. Actually, is this all the same lesson? Oh, these are backwards. That's sad. Now we'll see what happens here. So, just to recap some of the stuff that we did yesterday, these angles here are given to us there. We label them as x in the bottom corner there. So, what side lengths are the hypotenuse, the adjacent side, and the opposite side from that guy x there? Yes, Carolyn.
So the hypotenuse is always the longest side, so 5.83.
It's always the longest side. It's also found opposite the 90. So this guy right there is the hypotenuse. That guy is 5.83. Love it.
And the opposite is 3 centimeters because it's opposite from.
That is the opposite side. So that's good.
5 is the adjacent to the side, the x, and not the hypotenuse.
Perfect. Love it. And then these guys, this triangle here, same kind of idea. We've got the hypotenuse, the adjacent, the opposite side. We want those sides from this guy down here that we've labeled x. So which of these sides is the hypotenuse in this triangle?
5.
The side that is 5. Which one is the adjacent from that angle that we've labeled x? The 3. And then which one's opposite? The 4. Cool, love it. So one of the handy ways to remember these trig ratios and how they work together is this acronym here, SOHCAHTOA. Sometimes you'll see this written like this, which makes it look even more foreign language-y. And this is just a technique that helps us remember which sides relate to which ratio. So the sine ratio is equal to the opposite over the hypotenuse. The cosine ratio is equal to the adjacent over the hypotenuse. And the tangent ratio is equal to the opposite side of the adjacent side. Sorry? Sorry?
I was just saying, like, when we see the AD joint, to me it just looks like adjective.
Yes. But it's not. But it's, yeah. So let's flip the page here. Let's take a look at how these things actually work then. So if I wanted the sine of x here, the sine ratio as it relates to angle x, sine x is going to equal what?
7 over 9.22.
It's going to be 7 over 9.22. How'd you do that, Carolyn?
So for sin, it's O over 8.
So let's write them. I'll write it down at the top so we can reference it again. SOHCAHTOA. Sine is opposite over hypotenuse.
So the opposite from the x is 7.
Okay.
And the hypotenuse is 9.22. So it's 7 over 9.22.
That's the hypotenuse. Cool, love it. What about the sine from angle y up at the top there? Someone else. That one's going to be 6 over 9.22 because 6 is the opposite side there, and the hypotenuse is never changing. What would be the cosine of x?
6 over 9.22?
That's going to be 6 over 9.22. Because from angle x, 6 is the adjacent side, 9.22 is the hypotenuse. How about the cosine of y? 7 over 9.22. Well, that's interesting. Look at this. The sine of x is equal to the cosine of y, and the cosine of x is equal to the sine of y. That's interesting. How are the tangent ratios for each one of those?
7/6 for x, 6/7 for y.
So tan of x is going to be, sorry, what did you say, Rebecca?
7/6 for x, 6/7 for y.
There we go. There we go, 7/6 and 6/7. Questions, comments, concerns about any of that? Then I want you to take a couple minutes. I want you to do these last two. Okay, two triangles here. What are the sine and cosine and tangent ratios for all of those guys listed there? I guess I can get rid of this blue one sheet of paper. You guys were, surprise, surprise, Carolyn and Ty. Most back around the world the fastest.
Oh, right. Right place.
Right on their toes. Manraj, Bryce, Angel, Kyla, and Anna. You haven't finished yours?
We would actually do it.
You still can. Yes. Where?
We look at this.
Yep.
So, this for,
I did write it up at the top there. I'm not sure. You wrote it here too.
oh, I don't even remember doing that.
It happened.
Wow, wait, I actually don't really. That's concerning. I actually don't remember writing that, but I was very
It tells you how which ratios relate to which sides. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent.
So,
Yes.
this is the hypotenuse.
So we're looking at
These are all the same, right? Opposite, adjacent.
No, you have to depend on which side you're looking at here.
Oh, but
Every triangle is different.
these look the same.
Don't look at a previous question. Every triangle has its own problem. So if you're looking at sine x here,
Oh, right.
what side is opposite from x? And what side is the hypotenuse from x?
Am I going from the bottom of that? Here?
You want from angle x, what side is opposite of angle x? Okay, so there's two. So if sine is opposite over hypotenuse,